inequalities. Today we're going to talk about absolute value inequalities and equations. I don't know if you guys remember, but absolute values are those symbols. And what it is in an absolute value is we're talking about how far a number is away from zero on the number line. So if I'm talking about the distance something is from zero, you recall that that could never be a negative number. Nobody says I traveled -3 miles to get from point A to point B. You would say I traveled 3 miles. Distances are always given in positive numbers. If we're talking about football and the number of yards they carried the football, they don't say because he went backwards 3 yards that he went -3 yards. No, they would just say he went backwards 3 yards. It's still given as a positive number. He carried the ball however many yards, I don't know. So it's never given in negative amounts of yardage. Distance is never a negative number. It's always, always, always given in positive. So the same thing happens with absolute values. When I'm saying how far it is from zero, it's never going to come out as a negative. It's always going to be a positive number. So we're going to look at that today. We're going to look at how to solve some of these problems. But first, let's look at the vocabulary. You can pause the video and write down these terms if you would like. I highly recommend doing that so that you have them to look at. Absolute value, extraneous solution, this might be something new, and the empty set. So extraneous solution is just a simplified form of an equation that doesn't satisfy the original equation. We'll look at this more, and then the empty set doesn't have any answers, doesn't contain any elements. Just a reminder, I really pushed this, I think, in Algebra 1, but in case you didn't have me for Algebra 1, there are several steps involved when I'm solving an absolute value problem. Step 1 is always to isolate the absolute value. We want to get rid of everything else except for the absolute value symbols on their side of the equation. There should not be any absolute value plus something or a number being times by the absolute value. We always want just the absolute values all by itself. So that's step 1, isolate. Step 2 is then to make two cases. Remember, what's inside of that absolute value could be a positive number, and it comes out as a positive because remember we're talking about how far it is away from zero. So the number 3 is 3 units away from zero. But remember the number -3, if it was inside of that absolute value, we would also say that it's 3 units away from zero. So what's inside of the absolute value could be positive, or it could have been negative, but it always comes out as a positive. So we've got to check and see both cases, the positive case and the negative case. So we set up our two cases. Then we use the properties of equality, of course, to solve. And then it's important to go back and check our solutions. So I think this makes more sense if you do it rather than me just telling you. So first things first, we want to isolate this absolute value symbol. We want to get this 5x plus 1 all by itself inside of the absolute values. We don't want this -9 over there. We don't want this times 2. So the first thing I want to get rid of is this -9. How do I get rid of -9? Well, we add 9. If I add 9 to one side, property of equality says I got to add 9 over here. I realize it probably sounds like I'm beating a dead horse here, but I want to make sure that we understand whatever I do to one side, I have to do to the other. So if I have -9, I add 9 to get 0, I have to do it over here. So 17 plus 9 is 26, -9 plus 9 is 0, so it's gone. Again, I'm trying to isolate this absolute value. It has a times 2 outside of it. Well, how do I undo multiplication? None other than division. If I divide this side by 2, I've got to divide this side by 2. 2 divided by 2 is 1. 1 times the absolute value just leaves me with the absolute value. So come over here, and this is where it gets a little bit tricky. I have to divide everything over here by 2. I'm dividing everything over here by 2 because, see, that 2's outside of there, so you would kind of think like to distribute it. So since I'm dividing everything over here by the 2, I've got to divide everything over here by 2. 4 divided by 2 is 2. 26 divided by 2 is 13. Now we can begin really solving this problem. We have the absolute value of 5x plus 1 is equal to 2x plus 13. So we're going to make our two cases where all of this inside of here could have been exactly 2x plus 13. It's a positive. or it could be a negative and it just came out as a positive because it's the absolute value. So in case 1, we write it exactly the way it's written. In case 2, we've got to remember that all of this could be a negative. So I times it by a negative value. Okay, so let's work on case 1 first. We're trying to get our x terms together so that we can isolate the x. So I'm going to subtract 2x from both sides. Subtract 2x from 2x, I get nothing. 5x take away 2x is 3x. So I have 3x plus 1 equals 13. I've got to get rid of this 1. I do that by subtracting 1 from both sides. 13 take away 1 is 12. Now I want to get x all by itself. So divide both sides by 3, and x equals 4. Over here, first we begin by distributing negative 2x, negative 13. Again, we want to get our x terms together, so this time I add 2x to both sides, I get 7x. I want to get my non-x terms together on the other side, so I'm going to subtract 1 from both sides. Gives me negative 14, divide by 7, I get negative 2. So my possible choices for x are 4 and negative 2. We can plug them back in and see, does this make sense in terms of the problem? If I plug in a 4 and simplify on both sides, come all the way down here, I get 33 equals 33. That's a true statement. When I plug in my negative 2 and simplify all the way down, I get 9 equals 9. That's a true statement. So in this case, both x equals 4 and x equals negative 2 result in answer choices that work in the original equation. So both of those are possible solutions. We call the solution set 4 and negative 2. It's written in the fancy brackets to show that this is my solution set. Okay, something to watch out for. Don't forget to distribute that negative in case 2. I've seen people just put the negative on the 2x when they come to here. We've got to make sure that we distribute that throughout. Make sure that you distribute it. So whatever is my absolute value is equal to, put it in parentheses and put that negative outside of there so that you remember to make everything the opposite of what it was. Okay, moving right along. Extraneous solutions. This might be something new for you. Again, we're going to begin the exact same way. We've got to isolate my absolute value. Think about the word isolate. I keep saying it. I hope you know what it means. Isolate, if I said I wanted to isolate myself from everybody, that means I want to hole up in my room. I don't want to be bothered. I want to be left alone. I'm getting off all by myself. I feel isolated. I feel alone. I don't know about you guys, but with this whole virus thing going on, I definitely am feeling isolated. I'm talking to a camera instead of talking to my students right now. Makes me feel pretty isolated. I like communicating with you guys. But isolated means alone, all by itself. So when I say I want to isolate the absolute value symbols, that means I'm wanting to get those absolute value symbols all by themselves. I don't want anything else on that side of the equal sign except the absolute value and whatever's inside of it. So first I can see I've got to get rid of this minus x. I do that by adding x to both sides. Well, can I add x to negative 4? No, they're not like terms. But negative x plus x is 0. 3x plus another x is 4x. So now I have 4x minus 4 on this side. And I have 2 times the absolute value of x plus 1. My absolute value is almost alone, but it's got this nasty 2 there. We got to get rid of it. How do I get rid of 2 being multiplied by something? Inverse operation, I divide by 2. Again, remember, I divide everything by 2. 2 divided by 2 leaves me with the absolute value of x plus 1. 4 divided by 2 is 2. Negative 4 divided by 2 is negative 2, so I'm left with 2x minus 2. Now we can begin solving this problem. It's a lot of work to do just to get started, right? We've got to isolate, then we make our 2 cases. So case 1 is exactly like it's written. X plus 1 is equal to 2x minus 2. Case 2, we got to put everything over there in parentheses and have that negative outside of it. So we've got the negative here. We've got to distribute it throughout. A negative times a positive is a negative. A negative times a negative is a positive. We're going to isolate this x. But first, let's move this 2x over there with it. So I get 3x plus 1 equals 2, subtract 1, 3x equals 1, divide by 3, x equals 1/3. Over here, we're going to move the x term over here or over here, however the case may be. It looks like they moved it this way. So minus x, I get x. add 2. 1 plus 2 is 3, so I have x equals 3. Now we've got to plug it back in and check. It appears as of right now that 3 and 1/3 are my solutions. However, we got to check and make sure. When I plug in 3 and simplify it all down, I end up with 5 equals 5. That is true. But look what happens when I plug in 1/3. I end up with a -3 on this side and 7/3 on this side. So I end up with, even though we solved it correctly, mathematically we didn't make any errors in getting this 1/3, when I plug it back in, it doesn't result in a true statement. 7/3 is not equal to -3. Therefore, the 3 is my only solution. The 1/3 is not a true solution. So the solution set is the little fancy brackets, 3. It only includes the 3. And we consider this 1/3 an extraneous solution. It's a solution that we got mathematically, algebraically, we were able to come up with this 1/3, but it didn't make sense when I plugged it back in. Therefore, it's called an extraneous solution. It was an untrue solution. It didn't work out. Sometimes we end up with problems where there's no solution whatsoever. The solution is the empty set. Look at this one. We have the absolute value of 4x minus 7 plus 10 is equal to 2. Well, in our first step, we've got to isolate. So I subtract 10 from both sides. And immediately I end up with the absolute value of something equals a negative number. Well, we said it could never be a negative number. The absolute value is the distance a number is away from 0 on the number line. So there's no way that it could be negative. It would have to be a positive. So right off the bat, we can see that because the absolute value is always positive or 0, this sentence could never ever be true. Therefore, my solution is the empty set. We can write that as a 0 with a line through it, or we can just write an empty set of brackets with nothing inside. Both of those show that it is the empty set. I'm going to pause for a second. Okay, I had several emails I needed to check real fast. Continuing with our video, talking about football. The NFL regulates the inflation or the air pressure of footballs used during games. It requires that footballs have an air pressure of 13 pounds per square inch, PSI, plus or minus 0.5 PSI. So what is the greatest and the least acceptable air pressure of a regulation NFL football? Well, it can be 0.5 above or below the 13 pounds. We can quickly see that it could be 12.5 up to 13.5. It's got to be somewhere in between. So how do we show that using mathematical symbols? Well, let's look at it. We can look at it with absolute value symbols. So what is the greatest and the least acceptable air pressure? Well, we know the greatest acceptable air pressure is 13.5 and the least is 12.5. So we can know that our solution is reasonable because we can give an argument to defend it. But let's think about the absolute value of this. So the absolute value of the football's PSI can be greater than or equal to 0.5 above or below what it actually is supposed to be, which is what, 13, I believe it said. So we've got the weight, the actual, I keep saying weight, but the PSI of the football. If I was to subtract the 13, we want that value to be what? 0.5, right? Because it can be 0.5 to the right. It can be 0.5 to the left of 13. It doesn't really matter which way it is. So if we're thinking about this on a number line, the weight of the football is, I keep saying weight again, PSI is, ideally 13 pounds, but it can be to this side of it over here at this 12.5, or it can be over here on this side at 13.5. So the weight of the ball is somewhere in between, the PSI of the ball is somewhere here in between this 12.5 and this 13.5. And we can show that by taking whatever it is, subtracting 13, and it should be, the absolute value of that should be 0.5. All right, and that's going to take us up through the end of this video. We'll continue this lesson more tomorrow.